Lesson 8, Day 1, Understand Linear Functions. Think it through. What do the graphs of different functions look like? You've worked with functions that have a constant rate of change. You probably noticed that the graphs of functions with a constant rate of change are straight lines. The lines may start at different points on the y-axis, but they continue on a straight path. What is it about a function that defines its graph as a straight line? Are there functions whose graphs are not straight lines? These are ideas that you will explore in this lesson. So we're discussing, we already know about functions that are straight lines. We're also going to look at functions that are not straight lines, but they're still considered functions. So think, the graphs of some functions are straight lines. The formula for the perimeter of a square is p equals 4s. The perimeter is 4 times the length of a side. So the side length, if it was 0, then the perimeter will be 0. If one of the side lengths is 1, the perimeter will be 4, and so on and so forth. Examine the equation, the table of values, and the graph of this function. You can generalize equations such as p equals 4s as y equals mx. Here's another way to write the equation for this function. Y equals 4x, and 4 is our rate of change. The table and the graph show that the rate of change is 4. In the equation, y equals mx, m is the rate of change. The x and y are pairs of values in the ordered pairs shown in the table and graph. So again, looking at this table, we can tell what the rate of change is because we would look at our perimeter, which is our y, and our side length unit in units, which is our x. So to get from one y value to the next, we just add 4 every time. And to get from one x to the next, we just add 1. So our rate of change, our rock, is equal to our change in y over our change in x. And our change of y is always 4, and our change in x is always 1. So our rate of change is 4. That's how we got it here looking at the table. Looking at the graph, you can easily find the rate of change by, again, just choosing 2 points that you know for a fact your graph goes through. And one of those points is 2, 8. The other is 1, 4. So what you want to do again is find the change in your y's. So I have 8 minus 4 over the change in my x's, which is 2 minus 1. So I would have 8 minus 4, which is 4, and 2 minus 1, which is 1. So my rate of change again in my graph shows a rate of change of 4. All right. So, and then of course, looking at our equations are the easiest ways to find your rates of change and initial value. Your rate of change, as they mentioned here, is 4, and you know that because it's your coefficient. Okay. You would also be able to tell that your initial value here is going to be 0. And we know it's 0 because for a linear function, we have y equals mx plus b. M is our rate of change, and b is our initial value. Since in this equation we only had y equals 4x and no plus b, then if there was nothing there, then our b had to be 0, so our initial value was 0, which we could prove right here in our graph and table, because when x equals 0, y equals 0. And when the graph started, it started at 0, 0, so x was 0 and y was 0. So initial value is your b in your equation, is your starting output. In your graph, and it's going to be your starting output when x equals 0 in your table. So that's just a brief review of lesson 7, starting off lesson 8. All right, moving on. Equations in the form y equals mx yield a straight line when graphed. If the graph of a function is a straight line, it's called a linear function. So go ahead and underline that or highlight it or something. If the graph of a function is a straight line, it's called a linear function. The straight line indicates that there is a constant rate of change between any 2 points. Make sure you highlight that as well. The straight line indicates that there is a constant rate of change between any 2 points. Think, The graphs of some functions are not straight lines. Now let's look at the graph of the area of a square. So the area of a square is equal to s squared, or y equals x squared, putting it back in our y equals mx plus b. So when I look at this, we start off with a side length of 0. Of course, 0 squared is 0. Then you have a side length of 1. The area will be 1 because 1 squared is 1. Then you have 2 is your side length, but to find the area, you'd have to do 2 times 2, which is 4, and so on and so forth. So we have a constant increase in our side length of 1, but then our area in square units increases by 2 every time. Well, it keeps increasing up by 2. So you have plus 1, then plus 3, then plus 5, then plus 7. So this is not a linear function, as you can tell by the graph. So when I graph out all my points, I have 0, 0, 1, 1, 2, 4, 3, 9, 4, 16. I'm not going to have something that's super constant like that, okay? So this is not a linear function. It does not have a constant rate of change, because literally what's happening every time is just going to continue. The new difference is always going to be 2 more than the last, so it's not going to be constant. Its graph is not a line. Let's look at another nonlinear function. All right, another nonlinear function, we have y equals x squared plus 2. So again, we had y is x squared. That's going to give us a parabola. They didn't tell us that, but that's what that is called, a parabola, when you have x squared. We also have an x squared here, so we know this function is also going to give us a parabola. A parabola is what this looks like here. In this example here, this is our parabola. It looks like a U. All right, so then again, since we have our equation, we just like plug and chug basically. So y is going to be equal to x squared plus 2. So all they're doing to find their output values is when given their input values, they just plug that into their formula and find what the answer is going to be. So negative 3 squared is 9, plus 2 is 11. So that's where they're getting their ordered pairs. And of course, as an ordered pair, this is going to be negative 3, 11, and so on and so forth. Okay? Oops. And then you just graph it. All right, and so the graph shows that y equals x squared plus 2 is not a linear function. It's actually just going to be a parabola. Just like up here, and we only saw half of it because that's all they really showed us. They didn't give us any negative values. So. And the reason that they did that is because when you're talking about the area of something, you can't have a negative area. So they only showed you the parts that actually matter. All right, so give an example of an equation that is a linear function. So what was so different about the 2 examples they gave us on this page? So this one that we just reviewed was y equals x squared plus 2. The previous one above it was y equals x squared. But on our previous page, we started off with something that we knew, which was y equals 4x. What's so different between all of these? So remember, the equation for a line is going to be y equals mx plus b. And that's just pretty standard for our equation of a line. And the one that closely matches this, or that most closely matches this, is our y equals 4x. And the reasoning is because your x value is just an x. It's not raised to any other exponents. It's just an x. So that lets us know we're going to have a constant rate of change. But with the x squared, it's just going to continue moving up, where we can't really have that constant rate of change like here. In our area example, it just kept going up by 2s every time. Okay? Same thing for this one here. It decreased by 5, then it decreased by 3, then it decreased by 1, then it increased by 1, then it increased by 3, and increased by 5. Okay, so it doesn't have a constant rate of change. But this for our y equals 4x does. So the way that you know it's going to be a linear function is if your x value is not raised to any other power. So an example is going to be like you could say y equals maybe 13x plus 2, something like that. Or y equals 5x minus 4. The reason we know is because our x value or input or x is not raised to any exponent. Okay, and that's what our main point of today is, to understand what the differences between a linear and nonlinear function is. Linear, you're just going to have your x stand alone, but if it's nonlinear, it'll have x to some kind of power. Now, I want you to understand that just because when I say it's not raised to any exponent, I mean it's not raised to like 2 or 3 or 4 or 5. X is technically being raised to 1 here. Anything raised to the first power is just itself. So I don't want you to think that, well, it doesn't have an exponent. It technically has one, we just don't write the 1. Okay, so I just wanted to clear that up before we ended today. All right. Go ahead and move on to your practice, which is your workbook page, and you'll be able to check that off. And it is your workbook page 83 and 84. So practice in your workbook pages 83 and 84. All right, good luck.